All right, in this problem, it's another proof. We're told that BD is the perpendicular bisector of AC. Perpendicular bisector means it cuts it in half, it bisects it, and it meets it at a 90-degree angle. And we are asked to show that angle BAC, this angle, is congruent to angle BCA, this angle over here. All right, whenever you're asked to prove that parts of triangles are congruent, you must first show that the triangles are congruent. So this angle and this angle are parts of triangles BAE and BCE. So I'm going to show that those two triangles are congruent first. We're going to have to write a proof. Here are my statements. Here are my reasons. Okay, my first statement is just going to be my given. BD is the perpendicular bisector of AC. And that was given. You actually have to extrapolate what it is that tells you. So this told me that AE was congruent to EC. And it also told me that angles BEA and BEC are right. And that's because of the definition of a perpendicular bisector. I knew it just by knowing what the definition of that perpendicular bisector was. Okay, this allows us to also say that our angles, our right angles, BEA and BEC are congruent. The reason that I use for this is that all right angles are congruent. Some people say definition of right angles, and that's completely acceptable as well. We also know that these two triangles share this side. And they share the side, which means it's congruent in both triangles. So side BE is congruent to itself, side BE, by the reflexive property. All right. Keeping on going, now we have enough to show that these two triangles are congruent. Item number 5 is that triangle BEA is congruent to triangle BEC by, what do I have marked? I have a side, an angle, and a side. That's my reason for that, side, angle, side. And finally, since the two triangles are congruent, what we want to show is congruent can therefore be congruent. So angle BAC is congruent to angle BCA by CPCTC.